here we go. First of all, happy Friday. We're almost done with the week. This do now, it might seem a little familiar because it's something we've done before. This goes back to Unit 4. All right, so we are going back to graphing a little bit. Okay, but today we're going to learn a little more in depth about our graphing. But before we could do that, we needed a little bit of review. Okay, so this was one of the forms of graphing that we used. This was using the table of values. This was the very, very first thing that we did. Okay, when I'm using a table of values, like I said, the smaller the numbers you use, the easier it's going to be for you guys, right? If you guys are lazy like me, you're going to love working with those small numbers, right? So our first equation, Yesenia, what was our first equation we worked with on the do now?
Y equals 2x plus 3.
Plus 3. So Daniela, when I'm solving this, how would I solve for my first value of y?
Plug in 2 in the x.
I plug in my -2 into my x. So it's just a mini problem on the side here. Once I plug it in, I know through the order of operations, I have to do multiplication first. So y is equal to -4 plus 3. When I add -4 plus 3, my final answer is going to be -1. So that's going to be the first point that we could graph if we wanted to graph here, if I asked you for that. But that's the next step. We don't need to do that yet. Next one, -1, I plug it in. I plug it back into x. 2 times -1, I know is -2. And -2 plus 3 is +1. Now we're moving on the opposite side of our axis. Okay? From here on, you know that you can continue working through this, but do we need to? No, Daniel, why do we not need to continue working on?
There's a pattern.
You see the pattern. We know with linear equations, the reason why it's linear is because it makes us a straight line. So Daniel, what are my next 3 terms going to be?
It's going to be 2, +2, 4, 0? Oh, 3.
So on a number line, when I'm going from -1 to 2, -1 to 1, how many am I going up?
1.
Going up how many?
1.
It's all right. How many units from -1 to 1? If you need to use a number line, when I go from -1 to 1, how many am I going up?
Oh, 2.
I go up 2 units. So if I go up 2 more units, brings me to 3. Then?
4.
5.
Oh, 5.
It's okay. This is review. I know it. It's cool. Shake it off. Daniel, time to redeem yourself. When I'm going from 5, 2 units is
7.
7. And now if I asked you to graph, I would just graph those, plot my points, connect the dots, and that would give me my linear equation. Okay? I'm not going to go through number 2 because it's very, very similar to number 1. Okay? Any questions? All right. Make sure your name's on that. Set it aside. We'll come back to that. Okay? All right. So today, like I said, we're going to be going a little more in depth with our Unit 4 when we did graphing linear equations. I know that we all feel somewhat comfortable with graphing, but today we're going to go a little more in depth and we're going to see how it all kind of ties together. Okay? We're going to be coming back to our slope-intercept form, which is y is equal to mx plus b. That should be something that's familiar to most of us. And more importantly, we're going to be seeing what the similarities and what the differences are between graphs and how we write graphs and how we actually represent a graph. Okay? So, before we start our lesson, we're going to have a little discussion. This will tie into our lesson a little bit. But the word family. What do you think of when you hear the word family? Just not even thinking of math. What do you guys think of? Just off the top of your head. Let me get some hands.
Together. Groups.
You think of groups. What else do we think of when you think of the word family? Just in general. Don't even think about math right now. You think of a lot of people. You think of groups. What else do you think of family?
Together.
Something being together. What else?
Relates.
How something relates. That's a very, very good word. Relations. Relationships, right? What else? Okay, so now going a little more in depth, what do you think of when you start grouping families? How would you group a family together? How do you identify yourself with your family, for example? The same something. What's that something? Let's get a little more detail. We're going back to English class now. We're using some detail. How's your family different from somebody else's family?
DNA.
They have unique properties. There's something that's unique about them. What are those properties? Let's get very specific here. Their names are different. You probably have a pretty similar last name.
Characteristics.
Characteristics. You probably have, the same hair as your dad, or, you probably argue like your mom, or, stuff like that. You pull little things from your family. How about like religion, or race, or how you look? All those kind of stuff. This is the list that I came up with earlier. Your appearance, your culture, and your tradition. Some people celebrate different holidays different. That could be part of your family, right? Religion, your genes, and the list goes on. So the reason why I bring up family is today we're going to do an activity called Family of Graphs. We did something similar to this earlier this year, but we're going to go a little more in depth today, okay? Linear equations. So when we're graphing equations, they're very, very, very similar to when we were talking about families. Different graphs have different characteristics that make them similar and that make them different. And today, we're going to learn about those relationships and how different qualities of a graph make different graphs different, okay? So, to start it off, we're going to do it just like a normal day. We're going to start with independent practice. You guys are going to kind of explore on your own, and then we'll come together at the end. But I just want you to explore on your own. So, we're going to start with our colleges. Everybody remember what college you're in? Yeah? Okay, so we're going to start with our colleges. I'm going to assign you a worksheet. Everybody's worksheet is yours specific to yourself, okay? So the worksheet I give you, make sure you're working on that one. Don't switch it around with anybody else because you'll see it's going to come together in the end. Each worksheet, it's going to have 5 table of values. So just like you did on the do now, you're solving it the exact same way, okay? After you complete your table of values, you're going to plot your points and you're going to connect the dots, just like we learned when we graphed. And then you'll have 10 minutes. We're going to come back together as a group, and I'm going to let you know what to do. Got it? Okay, 20 seconds to get into your colleges, and I will meet you guys there.
Clean this up real quick.
Thank you. Just hold on to it. I want you guys to work this one. Guys, start on your own. If you guys got questions, ask your colleagues first, and then I'll come help you if you don't get it after that. All right, so now that you have it in front of you, let me clear it up a little bit. If everybody looks at the top, you have 5 tables. Under each table, you have a equation that coordinates with it, right? So on those equations, use the table of values just like you did on the do now. And from there, you should be able to get enough points that you could plot a line and graph it on the coordinate plane that I gave you. Any questions? Tom, so what are we doing? What's the first step in solving this? What do we need to do?
Putting the numbers into the graph.
You need to put the numbers into the table, right? And after I put the numbers in the table, Daniel, what do I need to do?
I don't know.
What do I usually do when I have a table of values? Why am I actually getting that table of values?
Oh, you put y equals mx plus b.
Y is equal to mx plus b, or you can graph using the plots, okay? Plot your points, and then we'll come back together in about 7 or 8 minutes. Okay? Go ahead.
These negatives, so like a negative.
Correct. So what happens when you have a negative and a negative?
It turns positive.
It turns into a positive. Good job.
2 plus 3, that's 1, that's.
So now that I start with my x values, what do I need to do to find my y values? So if I know that x is equal to -2, where's x in my equation here?
Here.
It is right there. And what does it mean when I have two values that are right next to each other? What operation is that?
Multiply.
It means to multiply. So if you want to write it out just like you did, -4 plus 3 is -3. Good job. So you know that every time your x is -2, your y is -3. Now you just continue to do that for all of them. Got it? Good job.
Which one's X and which one's Y?
What's that?
Which one was X and which one was Y?
So when you have your x-axis, which one is your x-axis? It's always the first one that we do when we're doing the slope. Remember rise over run? So is that telling me going to left or right or up and down?
Left and right.
Left and right. So your x-axis is left and right. And which one's your y?
I'm going up and down.
Good job. Gentlemen, how are we doing? And as Good job.
Yeah. Yeah.
Perfect.
Yeah. Better than you.
You guys got it. Good job. Questions?
I know what to do, but I'm confused when you said thing when it's here.
Okay, so your x value is -2, right? So if I look at my equation, what's my equation here?
X, y equals x.
Y is equal to x. So what the point of using a table of value is for substituting our x values for where we see x. So if I plug my x value, which is what here?
-2.
If I plug -2 into x, what does y equal? Try writing it out. So let's rewrite this, but instead of x, we're going to substitute a -2.
Equals to -2.
Yep. So what does y equal?
-2.
There you go. So you write down -2. So whenever x equals -2, I know y has to equal -2.
So all this is just basically over there.
Exactly.
We just point our plots over there.
Yep. So this one's a pretty simple one just because that's a reflection. They're the same. But once you move down, you'll see that you're actually going to have to do a little bit of arithmetic to figure out what your answer is going to be. Make sense?
Mm-hmm.
Perfect. How you doing?
Good.
Good.